Hello friends, Harshal here and welcome to my YouTube channel. So in this video I will explain the topic that is Docker. Docker is very important topic for exam perspective. So yes, let's get started. So what is Docker? So Docker is an open platform for developing, shipping and running application. So if you want to develop and shipping and running the application, then the Docker is for you, and it is also an open platform. Now Docker enables you to separate your application from your infrastructure so you can deliver software quickly. Okay, so first of all, let me explain you about Docker. So basically, if you want to run an application which is compatible with the Linux infrastructure or the Linux platform, okay, so that application you cannot run on Windows based operating system. Why? Because the application is basically made for running on Linux platform. Okay, so that's why you cannot run on your Windows operating system. Okay, so what you have to do, you simply create a Docker image, and that image you can run in a container. Okay, let us say you are working on Windows operating system and you want to run an application. So that application directly will not run on your Windows operating system. What you have to do, you should have the Docker image of that application. Okay, and that Docker image will automatically will be run on your Windows operating system. So yeah, it will work in this way. Okay, so I'll show you in demonstration that how can we do it. So okay, now with Docker you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. Okay, so wherever any application wants to test by the test engineers, in that case they share the image, Docker image. Okay, that Docker image that Docker image can run on any platform, on any infrastructure. Okay, whether if you are working on Mac OS, if you are working on Linux, Windows, so no matter. Okay, that image will run anywhere on any platform. It is compatible with all the platforms. So yes, you don't have to worry about if that application is relevant to it is Linux based application or Java based application or something which is running to a certain operating system or the platform. So we don't have to worry about that. Okay, so your developers write code locally and share their work with their colleagues using Docker container. So basically you can your colleagues can write a code and they can share the image or the Docker container, right? It's very easy to share those Docker containers or the image. They use Docker to push their application into a test environment and execute automated and manual tests. Yes, then when developers find bugs, they can fix them in the development environment and redeploy them to the test environment for testing and validation. When testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. So yes, pushing image, pulling image and pushing image. Okay, by using some Docker commands you can push the image, you can pull the image. That is what you can do. You can push the image from the repository, you can pull the image from the repository, and you can work on the code or the application. So yeah, pretty much we can do with the Docker. Okay, so okay, so here you can see here is the Docker host. Okay, let us say it is a machine, it is a local machine, and I have installed Docker image, a Docker daemon. Okay, first of all we should have Docker daemon running on our local machine. Once it started running, Docker daemon is active and it started running, then we can easily pull the images from Docker Hub, okay, or from the repository, okay, where the image is located. So we can easily pull the image by using that Docker pull. So once we pull the image, okay, and if you want to run that application, that image, if you want to run that image, then what happens? So, automatically a container will be created, and in that specific container, the Docker, the application will be running on that container. Okay, so this is Docker. Okay, so let me show you. So here you can see Docker docs documentation. Here you will get the documentation. Okay, so the Docker preview overview. Okay, then the Docker platform. So here Docker platform is used for develop your application, and it's supporting components using containers. Okay, the containers becomes the unit of distributing and testing your application. If you want to test your application, you should have that container. Okay, so it's very easy. Simply Docker run command will create a container, and your application will be running on that container. Then when you are ready, deploy your application into your production environment as a container or an orchestrated service. This works the same whether your production environment is a local data center, a cloud platform provider, or a hybrid or two. Okay, that's fine. Now what I use Docker for? So why Docker is required? So basically these are the points that I already explained you, that your developers write a code locally and share their work with the colleague using the container, or the test engineer will test the code. They can test the code. They use Docker to push their application into test environment and execute automated manual tests. When developers find bugs and can fix them in the development environment and redeploy them to the test environment for testing and validation. Then when testing is complete, getting fixed to the customer is as simple as pushing the updated image to the production environment. Okay, so now this is the Docker architecture. Okay, now this is important. Okay, that the Docker daemon. Daemon means the processes which are running in the background, that we call a daemon. So the Docker daemon listens for port Docker API request and manages Docker object such as images, container, network, volumes. A daemon can also communicate with other daemons to manage Docker services. So it basically manages the Docker services, right? Then Docker client. Docker client means where we are actually pulling the Docker. So that machine we can call it Docker client. The Docker client is the primary way that many Docker user interact with Docker. When you use commands such as docker run, the client sends this command to the Docker D means Docker daemon, which carries them out. The Docker command uses Docker API. The Docker client can communicate with more than one daemon. Okay, so basically what happened, let us say if we have typed the code, that is docker run and the image name of the image. Then what happened, that image will get downloaded from the Docker hub. Okay, and after that the container will be created, and there the application will get run. So this is what happened in the Docker client when you run this command, that is docker run. Okay, now Docker desktop. So here Docker desktop is easy to install application for your Mac or Windows environment. That is also available for Linux environment. That enables you to build, share, containerize application and microservices. Docker desktop includes the Docker daemon, Docker client, Docker compose, Docker containers, Kubernetes and credential helper. Okay, so it's an application, easy to install application for your environment. Okay, now Docker registries. The Docker registries store Docker images. Okay, it stores the Docker images. Docker hub is a public registry, so here also so many images, Docker images you will get here in the Docker hub, and it is for public use. So if you want to create your registry, you can create. Okay, for that ECR is used for the Docker registry. So I will make a video on this as well. In my upcoming video I'll discuss on it. Then Docker hub is a public registry that anyone can use, and Docker is configured to look for images on Docker hub by default. You can even run your own private registry. Okay, we can as well run the private registry. When you use the Docker pull Docker run command, the required images are pulled from your configured registry. When you use Docker push command, your image is pushed to your configured registry. Okay, now Docker objects. So when you use Docker, you are creating and using images, container, network, volume, plugins, and other objects. This section is brief overview. Okay, so there are a lot more. If you want, you can go with the documentation. So here is the URL docs.docker.com, and you will get a lot of stuff here to read. Okay, so let's go to our slides. So here, okay, so this is Docker. Okay, now what is the difference between virtual machine and Docker? Because Docker is also doing the same thing. Like if you want to run any application, okay, on your on Windows, okay, it is a Linux platform. It is compatible with the Linux platform, not with the Windows platform. In that case, what you generally do, you create a virtual machine. Okay, you enable the hypervisor, you create the virtual machine, and on that virtual machine you create virtual machine, Linux virtual machine. Okay, and after that you can install the application that you want, and you started using it. Okay, and Docker is doing the same thing. Okay, that basically the image you will get, in that image the new container will be created, and in that container you run the application. So both are similar, both are doing the similar things, but there are little bit difference. Okay, and the difference is that here hypervisor is used to create virtual machine, and in Docker, okay, that Docker daemon is used, and Docker daemon is very lightweight. Okay, it will not take so much memory. Okay, while here in a virtual machine it is logically separated. All the virtual machines are logically separated, and it takes a lot of memory. Okay, and your machine will maybe it gets slow because it running a heavy job, and here it is lightweight and it will not take that much memory to run. And yeah, so that is why Docker is important, and yeah, and I prefer Docker over virtual machines. So here you can see there is an infrastructure, and let us say we are using Windows operating system. I have enabled the hypervisor, and let me create the virtual machines. If I create 3-4 machines, then my local machine will get slower, I mean a lot slow. Okay, that I cannot run anything. And then on virtual machine I can install the application. So here what I have to do, simply there is an infrastructure, my local machine, and the operating system is running on my my local machine. So it could be anything, let us say EC2 instance. Okay, and then the Docker I need to install. That Docker daemon will started running, and after that Docker daemon I can simply pull any image from the public registry, and I can run that image. So automatically that container will be created and started running. So basically it happens. So in this way it will work. Okay, so there is a Docker file, it will build. Okay, it will be built. Then image Docker, that image, if I wanted, I can pull the image, I can push the image to Docker Hub or Amazon ECR. Then if I run the command, that is docker run, then it will create a container, and that application will get started running. Here are some basic Docker commands, that is docker pull to pull the image, docker image if you want to check the image. In fact, if you want to check the logs, docker log will be used. Then docker run to create to run the application, and to run the application, container needs to be created, so it will be automatically created and started running. Then if you want to check the processes, then here is the command. If you want to check the processes, all the processes which are running or not running, so everything you can see here. And this is for detach. If you wanted to run the application but that application was not completely attached, okay, then -d, you can use -d and image name, and it started, you can show, and it started running. Okay, that detach image, detach process will started running. If you want to stop, you can stop the container, you can start the container. Okay, then we can also run hyper p, means this is port. If you want to binding or dynamic port binding or port forwarding, you can do that. We can give the port name, and there is a container port and the image. Okay, so we can use the docker commands, and if you want, let me show you that docker. Okay, docker. Okay, if simply run that docker, and here you will get a lot of option. Okay, so for debug, this is for version. If you want to check the version of docker, you can use -v, and here are some of the command. Okay, for the management command, and if you go down, here is some commands, that is build command to build an image from a docker file. Let us say if you have a docker file, then you can build an image, docker image. Then this is for commit, this is to create a new container. Okay, then this is to list images, to check info, to kill running containers. Then there is a ps to list containers or the processes. Then yeah, a lot of things to restart the container, to rename the container, and start, stop. So you will get a lot of commands here as well. So I'll show you that how can we do that. Okay, okay, let me go here in the Docker Hub, which is the public registry, and let me go here and write httpd. Okay, so this is the, I just wanted to run httpd, right? So this is the image name, that is httpd, and that tag is important. So here are the tags, right? Supported tags. So these are the tags. So you can use any of the tags. If you go here and if I click on it, that is tag. So let us say if you want to run specific version of httpd, then you can mention that tag name. Okay, tag means here we can simply call it a version, right? So it is similar to version. Okay, let me show you that how can we pull. So first of all, I have already let me show you, I have already installed Docker in my system. So if you don't know how to install Docker in your system, then I'll put the link in the description box, so that you can check my previous video where I have already explained how can you install Docker on Ubuntu. Okay, so it's very simple: docker pull and image name. So here is the image name, that is httpd. Okay, if you simply do that docker pull httpd, then the latest version of httpd will be downloaded. Okay, httpd image, docker image. And if you want some specific version, then simply go here, and here is 2.4. okay, let me check. Here is the 2.4. I want to install that specific version. So here 2.4, and it will start running. So it should have that privilege. Okay, it started downloading. It will download the image. So download completed. And if I want to check the image, then I can check with the docker image command. So it will take some time to download the image. So yeah, it's 23 MB, so it will take some time. So here now the downloading is completed, and we have successfully downloaded the image. So if I wanted to check the image, then simply run this command, image. Okay, docker image -a. No, we need to run some command, list images. Okay, that is ls, docker image and ls. So here you can see there are two images which has been downloaded in my system. The first one is Redis and the second one is httpd. So there are two docker images I have. Okay, so this is image id, right? And okay, let me run one of the image. Okay, let me run httpd. So docker image docker run image name is httpd. Okay, 2.4, or you can run any image. Okay, so let me 2.4. okay, so it started. Could not reliably determine server's fully qualified domain. Okay, there is some configuration issues. Docker image docker run Redis. So here you can see that Redis is starting. Okay, and I guess there is some configuration issues. That port is assigned to the image. Okay, I'm getting some issues with the Ubuntu. So let me Control C. So but this is the way you can run the docker image. Okay, so I will tell you on EC2 Linux, EC2 instance, because here I'm facing some challenges here. So let me go here in the AWS and here in EC2. The instance, and let me launch the instance. key pair okay, so I have launched an instance, EC2 instance. So let me go there. Okay, let me go here, view all instances. So the instance will be shown here, right? So it is in running state, and yeah. So now I have to connect to that instance. So let me go to security group. I'm going to the documentation, AWS documentation, where I will simply check it out that how can we install ECS agent or the Docker. Okay, simply how to install Docker, not ECS. Install Docker. I need to check how to install Docker. So here let me search again, and Docker on AWS. So I hope that here I will get Docker, how to install Docker. So here how to install SAM. Okay, so here how installing AWS SAM on Linux, right? So this is serverless application module. I don't want to install that serverless application module, but here if I go down, there is some Docker here. Okay, here is the process how to install Docker. So here you can see that install Docker. Okay, it is optional process, but yeah, we need to install Docker. Okay, now here first of all sudo yum update. So let me go here. Okay, let me connect it to SSH. cd home duck download. If I do yes, so here is the SAM PEM. Okay, so yeah, we have taken SSH, and now where these commands we have to run to install Docker in EC2 instance. So yes, so yeah, we have updated the packages. Now install most recent Docker Community Edition package. So this is Docker Community Edition package. Let me run this command and it will start it running. So yes, So we have run the command successfully. Now the next command is sudo service docker start, right? So now we have to start the docker service. Simply copy and paste. Yes, redirecting to bin systemctl start docker.service. Now add ec2 user to the docker group so that it can run docker commands using sudo. Okay, so you need to run docker commands using sudo. Okay, done. Now the next is, okay, now I can check the processes, docker processes, to verify. So what is this? Got permission denied while trying to connect to the docker daemon socket at dial version socket connect, permission denied. Okay, why it is denied? The permission got denied. Okay, because it is not the sudo. Okay, then let me go here, sudo docker ps. Okay, sudo user or the privileged user should be run the command. Okay, so now here you can see container id, image, command, so everything, all the columns we can see here. And if you want to check, so docker -v, it means version. So docker version, here you will get the docker version. So docker has been successfully installed in the system, and let me now docker run httpd. Okay, so what happened, latest version of the httpd image will be downloaded, and it will create container and it started running. So everything will be done just by running this command. Okay, if you want to download the image, then you can simply type here pull. Okay, it will only pull and download the image. But if you run the command, then it will download and run the command. It will create container and run the command. Okay, so everything will be done. Okay, so let me go with this. So yeah, sudo, and it started downloading. Okay, first it started downloading, then it started creating download image for latest. Okay, then it will create container and started running the command. So httpd could not reliably determine the server's fully qualified domain name, and okay, okay, so it is taking too much time, so let me cancel it. So if I have done cancel, it means that the image is not running, right? But the container has created already. Okay, it is the different, it is if I can say that container has not been created, no, it's wrong. Okay, container has created. Only thing is that the application, that image is not running. Okay, I have simply cancel it by Control C. So if I want to check whether docker is running or not, so sudo docker, which docker process is running or not. So let me go and check ps. Okay, so you can't see anything. Okay, there is no container id, no image, nothing. Okay, if I simply do -a, so it will show the container id, the image name, okay, and the command and everything. Okay, this is port, no port has been assigned to it because that service is not running, right? So it will show running application and non-running application both. Okay, now there are more commands. Okay, so you know very well that how can we use that docker run, how can we pull the image, how can we see this is docker image ls. Okay, then you know process -a. Okay, now if you want to run detached, right? So let us say that httpd is detached. So let me run that command. Where is here? So let me run this command and image name. So copy, and here I paste it. Okay, and httpd. Okay, container is created, but application is not running, image is not running. Okay, so that is why I want to write the flag that is detached, and let me try again. So it is not, command not found. I guess there is image or container ID. Let me docker ps. Okay, it is not in privilege mode, so let's do sudo docker run -d httpd. Docker ps sudo docker ps -a. So this is command, copy, it should be run with this command. So latest, but it should be run with that d. Okay, if that is detach command. So yeah, it's not working for now. Okay, let's go forward. Let's go to the next topic, that is next command, that is docker stop. So for stop the docker, for stop the docker process, you can write the container ID here and start the container ID. Then here you can we can simply give the port number, host port number, and the container port number. Okay, so whenever you go here in the docker hub, okay, so in the description you can see here, where is, here is the port number. Okay, so the port number for HTTP is port 80, right? And that is the port number, that is 8080. It is by default. And if you want to change the port number, you can change the port number of the host port. Okay, and that will be binding with the application port, HTTP port. So this is what happens. So if you want to change the port from 8080 to 62913215, okay, like that, 4 digit, then you can do that by using this command. So let me copy this command. So here 3422. Okay, I want to set this host port on port container port, that is 80. It will not work because the HTTPD is not running, but still let me yes, it's not running, but this is how you can do that. Okay, you can do this. Okay, so let me exit this. Let me go here, and now okay, now we have to start the application, serverless application, sorry, that module. Where ECS Elastic Service, Elastic Container Service. So here okay, here in Amazon ECS, it is taking time. Okay, now here in Amazon Elastic Container Service, so here what happened, there are basically let me do that, get started, and here we can see the diagram, block diagram, and this is the container definition. It means that we have to we should create container. Okay, it will created a container. Then task definition, we have to create the task definition, we have to configure the task definition, we have to configure the container definition, we have to configure the service, and we have to create the cluster. So these are the 4 tasks that we have to do. So this is the diagram of ECS objects and how they relate. Okay, so we can simply now I simply cancel it. So first of all, let's create cluster, and before that let me read something about cluster. So all Amazon ECS cluster is a regional grouping of one or more container instances on which you can run task. Okay, so if you want to this is the regional grouping. Okay, this is an Amazon ECS cluster is a regional grouping, or we can say that it is an logical grouping of EC2 instances. So EC2 instances run the ECS agent here. Okay, first of all I have to create a cluster. This is the logical grouping of EC2 instances, and after that EC2 instances run the ECS command. So automatically the ECS ECS AMI will be automatically created. Okay, we don't have to basically install ECS agent and all the stuffs that we don't have to do that. It will be automatically created, and then the ECS agents register instance to the ECS cluster. Okay, automatically it happens, it will register the instance to the ECS cluster, and then EC2 instances run a special AMI made specifically for ECS. Okay, this is very simple. So let me first create the cluster, and here we can go with the networking only, we can go with the EC2 Linux and the networking. Here we have to set the cluster, VPC and subnet, that's it. Okay, and it will use either WS Fargate or the external instance capacity, but we want to create EC2 instance, EC2 Linux instance plus networking. Okay, so I want to define EC2 instance, I want to create EC2 instance in a cluster, or if you want to EC2 instance with the window platform, so you can do this, but I will go with EC2 Linux plus networking. So next step, and here ECS cluster. Okay, right, now we can also create empty cluster. If you don't want to create EC2 instance in the cluster, EC2 instance and the networking configuration, you don't have to do that, only you have to create some empty cluster. So you can simply click on it. Okay, and directly cluster will be created, nothing will be created besides that. But if you want to set EC2 instance, if you want to create, if you want to launch EC2 instance, okay, then you can do that. So here there is a on-demand instance. With on-demand instance you pay for compute capacity by the hour with no long-term commitments upfront. Upfront payments means in advance. Okay, you don't have to pay upfront payments. Okay, so only you pay for compute capacity by the hour. right? So there is no long-term commitments up or upfront payments. Okay, so yeah, this is good option for me. And there is a spot means Amazon EC2 spot instances let you take advantage of unused EC2 capacity. Let us say there are some EC2 instances, okay, and those EC2 instances have a higher cost that nobody is using. Okay, after that what happen in the AWS cloud, spot instances are available up to 90% discount. So there is a 90% discount. Why it is getting 90% discount? Because nobody is using these instances. Okay, so you are getting 90% discount and for spot, okay, and on demand prices. So I'm good with on demand instance. Now for free tier I'm using T2 micro, and number of instances I would like to create, that is 1. You can select number of instances you want. Okay, and this is EC2 AMI ID. So EC2 AMI ID, it means that it will run a special AMI, okay, which is ECS enabled special AMI will be launched. Then EBS volume size, and here I can use the key pair. Here create new VPC, I don't want to create, I'll go with the default VPC. And let me select the subnets. So all the subnets I would like to select subnet or AZ. Then use subnet setting, yes, I would like to use subnet setting. Then security group, I would like to create new security group. Then security group inbound rule, so okay, I'll go with this. Now container instance IAM role, if you don't have that ECS instance role, then you can simply create new role directly. You can select this option. If you have it ECS instance role, then just click on it. So container instance IAM role, so what happened here, the IAM role to use with your container instances. Okay, this is for the container instances. Okay, now here do not confuse with the EC2 instances and the container instances. EC2 instances means the instance that you have launched, okay, that T2 micro instance, that is the EC2 instance. Okay, and container instance means a number of containers that will be created inside the EC2 instance, and every container has its ID, and that we call it container instance. Okay, okay, we are good here, and let me create. So ECS cluster is getting created. So ECS instance IAM policy is also created. It is successfully attached, and the cloud formation stack will be created. So these three components will be created. The first one is ECS cluster, ECS instance IAM policy will be attached, and the cloud formation stack will be created. Okay, and okay, let me view the cluster. So here this is the cluster, right? Let me view all. So this is the cluster name, that is ECS cluster, and if I click on it, so here is the ARN number of the ECS cluster, and here inside the cluster, here is the service. Okay, there is no service we have created. Then there is a task, there is no task is running because we have not run any task, we have just created the cluster, that's it. Then ECS instance, so here you can see there is a ECS instance. Why there is a ECS instance? Because this is a container. ECS instance means, okay, so ECS agent will be running on EC2 instance, so that's why this container instance is created. So ECS instance already is running. okay, because we don't have to install ECS agent and all the stuffs. It will be automatically installed, okay, because EC2 instance is ECS agent enabled. So here you can see CPU available, that is 1024. So total 1024 CPU is available. Memory available, that is 982. So it should be like 1024 or 1 GB, okay, and now it's 982 megabyte MB. Then there is a agent version, okay, and this is the Docker version. So this is the agent version 1.61.3. So the agent will be ECS agent, okay. This is instance ECS instance, and this is container instance. So yes, we are good here. Then metrics, so there are some metrics you can monitor, okay. Memory utilization, CPU utilization, memory reservation, and CPU reservation. Then schedule task, here you can schedule the task. So right now we have not defined the task definition. So okay, now tags we can add. Then capacity providers means that auto scaling group and load balancer, okay, so that kind of things. Okay, so now we have now created the ECS cluster. The next step is that to create task definition. So now I would like to create a task definition. So we are not going with the Fargate for now. I'll create a video on Fargate. For now I'll choose EC2 instance. Now next step, give the service name, that is ECS, okay, HTTPD task. Let me check that HTTPD task. Then task role, no need to create a task role for now, optional, it is an optional IAM role that task can use to make API request to authorize AWS services. Create an Amazon Elastic Container Service task in the IAM role. So if there is a specific task that needs IAM role, so in that case you have to create that task role, okay. So I don't need any task role for now, so I'm good with it. Task execution role, so okay, let me select this. Let's see what happens. And task execution role, that is none. Here 300 megabyte MB, and this is 300 MB. And now we can add the container. So let me do none here. Let me add the container. So container will be HTTPD service, okay, container, HTTPD container. So now here you have to write the image, that is HTTPD, and 2.4 is the tag, okay. This will run the instance, this will run the image from here, that is Docker Hub, okay. Now the next one is hard limit, that is let me write 128. You can also add this soft memory limit. And port mapping, here 8080, let me port mapping, and the container port is of course 80. Then no need to do health check. environment. Okay, I would like to keep it simple, and let me add this. So yes, it is added, and integration constant. So here we have given the name EC2, that is not required. Then I am task execution role. So let me okay, fine. So if you want to add some volumes or ABS, you can simply add the volume here, and let me create first of all. So it is successfully created. So task definition is created now. Okay, so if I go to cluster, and here you can see ECS cluster, right? And inside cluster, if you click on it, so there is no, okay, here in the task, so here HTTPD task, right? So this is the task. Okay, we will add this task to service. So first we have created the cluster, then we have created the definition task. So basically definition task are metadata in JSON form to tell ECS how to run a Docker container. So it contains some crucial information like image name, port binding for container port, image name. So you know that HTTPD image name that we have defined in the container. Okay, then port binding also we have added, that is 8080 port. This is for the host port, and the 80 which is for 80 for the container port. Okay, now the next one is memory and CPU utilization required. Okay, for running the container, for running the application. So that is why we have given 300 MB to memory and CPU both. Environment variables created and networking info also we have added. Okay, so everything we have done in the task definition. Now let's go and create some service. So in the cluster, there is a cluster, and let me create a service. So here you can create the service, okay, inside here. So ECS services, basically it helps define how many tasks should run and how they should be run. Okay, they ensure that the number of tasks desired in running across our fleet means across the EC2 instance, then they can be linked with the elastic load balancer or network load balancer, then application load balancer if needed. Okay, so we can add the load balancers. Okay, so let's create EC2 ECS service. Now create it. So we will select EC2, and now let me select that task definition. Okay, there are two task definition. I'll select that HTTPD task. Okay, it has one revision. Okay, how to create different version or different revision. Okay, so we can create different revision for a task definition. Okay, so I'll show you later on. So first of all, we have only one revision. Then cluster, it will be ECS cluster, only one cluster. Then the service name, that is HTTPD service. Let me give the name, that is service. Okay, okay, so now here you can see there are two options, replica and daemon. Okay, so what is replica and what is daemon? So if you want to create multiple tasks, multiple containers, okay, if you want to create multiple container and run multiple application, okay, then replica is for you. If you want to run application on different EC2 instances, right? So in that case, you can choose daemon. So here if I simply hover the here I can hover, okay, then you can see that the replica services place and maintain a desired number of tasks across your cluster. So it is within cluster it will create. And daemon services place and maintain a copy of your task on each container instance. If capacity provider strategy is used, daemon service type is not supported. So here basically what happened, so so everything will be you can run multiple tasks, you can run multiple tasks on single container, okay, but here in daemon only one task should be run on one container. So this is the difference between replica and daemon. Okay, so number task I would like to run, that is only one for now. So minimum will be, let me select 0, and maximum will be 200. Okay, so deployment circuit breaker, so here enable with no rollback, enable with rollback, so I don't want to go with this for now. Then there is a rolling update and blue-green deployment powered by AWS Code Deploy. So you know very well that what is, how to use blue-green deployment, and it is basically it is the older, okay, and we are basically going with this, that rolling update. So if you don't know what is rolling update, then simply just hover cursor here. A rolling update replaces the current version of the task in the service with a new version to control the number of your service task in the running state during the deployment. Set minimum healthy percent and maximum percent values. Okay, here what happen, if you select that deployment type, that is rolling update, it means it will automatically update the version. If there is a new version, it will automatically it will set. Okay, you don't have to manually set the newer version. So that's why rolling update. And now task placement. So yes, easy balance spread, choose that, and then okay, let's go to next. So okay, I have not selected, so let me select, that is EC2, and now okay, now next. So now we are here in the configuration network. So this is for network configuration. So here we can set the load balancer as well, but for now I don't want to set any load balancer. So there are basically 3 load balancer: application load balancer, network load balancer, and the classic load balancer. So for now I don't want to use any one of them, and go to next. Okay, do not adjust the service desired count, that is fine. Then here, okay, no network configuration has been configured, and then auto scaling is not configured as well. So now service is created, and let's check the service. So okay, now we are in the cluster, that is ECS cluster, and inside cluster you can see the service, and here inside the service we have attached the task definition, right? So first of all, create ECS cluster. Inside ECS cluster we can create a service where we can attach, where we can add task definition. So that is basically we have done till now. Okay, fine. So now this is the task, and you can see it is running. Okay, it started running. So it started running, and this is the HTTP task, and that is the revision 1. It means that revision 1, and this is the task ID. Okay, and this is the container. It is running on the container, that is the container instance, right? And now Okay, let me go here. Let me go to EC2 and let me check if it has successfully. So where is it is successfully running or not? Okay, so let me, so here you can see that EC2 instance which is containerization enabled, and here there is public IP version 4. So click on it and let me go here and I paste the public IP, and here port is 8080. Okay, so let me check. So I guess it is taking too much time and it is not working. So why this URL is not working? So okay, so for that reason I have to check the security, that is security group. So let me go inside in the security group. Okay, in the security group, okay, here you can see the security inbound rule. Let me go here and inbound. Let me add anywhere. Port should be 8080, right? So let me delete it and let me save it. Okay, so now let's check. Yes, it started working. So yes, it works. Okay, so now we can see the HTML page. Okay, and if I go back, let me go here in the EC2 instance. Where is, okay, here is the EC2, and let me connect to the EC2 instance. So I'm taking SSH, so not accessible. Okay, no key is there. Control C, duck, then downloads. I guess it will not work because we have not added SSH. Yeah, I go to EC2 and I need to add SSH port. That is 22. Where is, there is a security. This is security group. And okay, we have not added SSH here, so let me add, that is SSH. This is port 22 and anywhere. So okay, now Control C, let me try again. So yes, now it's working. So here if you want to check Docker PS, so here you can see the container ID. Okay, and that is it is redirected to 80, the port 80. Okay, host port is 8080, which is binding with the container port, that is 80. So this is how it's working. And okay, and if you want to check that is curl localhost 8080. So here you can see it works. Okay, so basically this is the body which is written it host. Okay, if you want to check the logs, then simply go to docker and logs. So yeah, it will not work because we need to add container. So let me go and check the container. Okay, here is, so this is container. Yes, this is container. So paste here and it will show the logs. So I guess this is not the container ID. Okay, so this is these are the logs, right? So the system, the how it is running and the events when it started running, HTTP image, so everything you will get here. And this is all the logs. You can check it out. Okay, so now if I want to go here in the services, in the cluster first. Okay, and in the cluster there is one service, one running task, okay, and one container is instances. So basically what happened in our EC2 instance, that is ECS cluster. Okay, inside the ECS cluster there is EC2 instance, and in that EC2 instance, that a container instance has been created, and inside that container instance a service is running. Okay, that task is running. The one service is created and the task is running, that HTTP task is running. So this is exactly how it is. Now if I click on it, and now this time I wanted to run two services or four services, right? Four tasks I wanted to run on the same container. So let me go here. Let me go here and let me update. So here there is number of tasks. Let me select 4. Okay, but before that, okay, it will not work because we need to revise. We need to add the revision. Okay, so this is the old revision. So let me go back first. Let me cancel it. Let me go to task definition, and I wanted to create new revision. So okay, here no need to EC2 instance, and here in the containerization, first of all go to containerization. Okay, HTTPD. So no, okay, here this is the container. Okay, we just need to click on this container, the same container which was already created. We don't have to add new container, and here simply go here and simply just remove the port. Okay, so that it will take random port, right? If we have given a specific port, then the only service will be created. No different task will be running. Okay, no different task will be running, or no different container will be created because of that. Okay, so that's why just blank, put it in a blank. and go down and update it. So now it is updated, right? And now go to the cluster, go to inside EC2, and here update the service. So this time the revision will be okay. Why it is not showing revision? Let me go back in the revision, create new revision. Okay, there is no port for now, and let me update. After update here, okay, I had not created. Okay, so here now created. So here you can see the port is okay, not here. I cannot see here. Okay, inside. Okay, so here you can see host port is 0, container port is 80. Okay, TCP protocol it will use. So yes, done. So we have done, and this is the version 2. Okay, revision 2. So revision 2 is created, and now go to cluster and click here, and inside service you can add, this is the okay, so here we can update the latest. Okay, that is 2. And now I wanted to create 4 tasks. So 4 container will be created and running 4 tasks. So go to next, 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 and update service. So yeah, it is updated. Now view the service. So desired, now you can see the desired count is 4. In the cluster, if I go here, now you can see there are pending task is 3. Okay, 1 task is successfully running, 1 container has run. So it will take some time to run all the tasks. If I go inside, and yeah, there is running task count, that is 3. So if I here is the task. So there is 3 task is running. So out of 3, 1 task of 1 active service count, right? Register container instances, that is 1. CPU available, that is 124, memory available, that is 82, and schedule task, no, then tags, capacity, provider. Okay, right. So now desired is 4, but it is running only 3 because short of memory. Okay, that's why it is running only 3 tasks. Why it is short of memory? If I go to here in the task, not here, EC2 instance, here the memory available, that is 82, which is not sufficient for running the 4 tasks. So that is why only 3 running task is 3 task is running, right? Okay, that is fine. So at least 3 is running. So if I go to that instance container instance, so yes, these are the container instance, and every container instance has different every container instance has the same port, but the host port will be different. So if I go to here, so this is active and running. Where is okay, so go here, let me show you the ports. Okay, so here Docker and PS, right? So now you can see there is 49155, 49153, 49154. So the host port are different because we have not set any of the port, we have not defined the port, specific port. So that's why randomly it has taken the port, that is 535455, and the container port will be the same, that is 80. Okay, so this is how the binding is, 55 and 53 to 80 and 54 to 80. So basically 3 containers created, and these are the container ID, that is 1 2 1 2 and 3. Okay, 1 2 3, and this container ID is for the ECS agent, right? So yeah, there are total 4 container. Okay, so this is the 4th container, that is ECS agent. So in 1 container that ECS agent is running, and in 3 container that HTTP task is running. Okay,